data, ensuring that AI models are trained on clean, validated, and privacy pursuing data sets. With blockchain's cryptographic techniques, users can maintain control over their own data, allowing them to decide what is shared and how it is used in AI, generative AI system while maintaining privacy and consent. So generative AI can provide the functionality of smart contracts on blockchain platforms. It is also blockchain has already enabled to raise non-fungible tokens, which allows the creation of digital assets that are unique and variable. Generative AI can be used to create unique digital art, museum, and other media, which can be tokenized on the blockchain to ensure authenticity and ownership. Both the blockchain and generative AI could enable more efficient distributed computing models. Blockchain could facilitate the sharing of unused computing power for training AI models across a decentralized network of machines. This decentralized AI computing could democratize across to generate AI models, making powerful tools accessible to smaller companies, researchers, or individuals without the need for a massive server infrastructure. Supply chain innovation, AI enhanced decision making for decentralized finance, generative AI in healthcare, tokenization of AI models and data, revolutionary of ethical governance, virtual worlds and metaverse, AI-driven legal and intellectual property solutions are some of the fields that we can go in depth by using the both techniques, blockchain with AI generative models. Therefore, there are a lot of challenges occurs in this to secure the data. So the challenges what we are going to take that one is called the scalability. A blockchain, particularly in public networks, faces scalability issues. Generative AI models, especially large ones, also require massive computational resources, which might not always align with blockchain's current performance capabilities. Another is energy consumption. Both blockchain and generative AI models can consume significant amount of energy, which would hinder their widespread adoption. Regularity complaints. Uh, the convergence of blockchain and AI, generative AI, might face security from regulators as both technologies evolve faster that existing regulatory frameworks can adopt. Security. While blockchain offers strong security, AI models are still vulnerable to adversarial attacks, which can compromise the integrity of data and the model themselves. So, some of these challenges that you have to face in the future by studying blockchain technologies and generative AI models, so which requires a different innovative ideas and other algorithms to be needed to be developed. So therefore, this FDP program is going to give a lot of the inputs, right, from the resource persons, such that you can take these challenges and think about the innovative ideas, such that you can do more number of projects on blockchain and AI, generative AI in combine, right? So this is demanding problems that we are going to face and have some innovative ideas. So therefore, I request all the participants to put your concentration and regularly interact with the resource persons and get your ideas to be clarified and how the blockchains will help in generative AI to make more number of the structures, right, and to solve the problems in all the fields, especially in the security system and maintaining very big data problems, right? So therefore, I request again that you have to concentrate on these technologies, right? And learn lot of things. In 6 days, I hope that you will learn lot of things from the resource persons, and you'll have a good exposure, and then you have the clarity such that you can get lot of the outcome of the FDP, right? Can you will help you right further to do lot of research work on this blockchain and generative AI techniques, right? So therefore, this FTP will help you a lot for you as well as the students, right? To do the many project work on this. So once again, I welcome all the participants and thank the uh, management and Department of IT for conducting such great FDP program on this. So thank you very much. Thank you.
Thank you, sir, for your encouraging words and for setting the tone for this program. With this, we conclude the inaugural session of our FDP on unlocking innovation with blockchain and generative AI. I extend my heartfelt gratitude to all our distinguished dignitaries, our Principal Sir, Dr. Y. Mallikarjun Reddy, our Dean of Academics, Dr. K. Giribabu, and our HOD, Dr. Kalavathi Alla, for their inspiring contributions. Your words have truly set the stage for what promises to be transformative learning experience. I would also like to thank all the participants for joining us and making this event a success. Your enthusiasm and commitment to learning are what make such programs meaningful. Now we are excited to embark on the academic journey of this FDP. Let us dive into the first session. Our first session is on overview of blockchain technology, a foundation for understanding one of the most transformative technology of our time.
Sai Jyoti?
Oh, sorry, ma'am. Sorry, I have unmuted just now. Thank you, sir, for your encouraging words and for setting the tone of this program. With this, we conclude the inaugural session of our FDP on unlocking innovation with blockchain and generative AI. I extend my heartfelt gratitude to all our distinguished dignitaries, our Principal Sir, Dr. Y. Mallikarjun Reddy, our Dean of Academics, Dr. K. Giribabu, and our HOD, Dr. Kalavathi Alla, for inspiring contributions. Your words have truly set the stage for what promises to be transformative learning experience. I would also like to thank all the participants for joining us and making this event a success. Your enthusiasm and commitment to learning are what make such a program meaningful. Now we are excited to embark on the academic journey of this FDP. Let us dive into the first session. Our first session is on overview of blockchain technology, a foundation for understanding one of the most transformative technologies of our time. To formally introduce Dr. Kalavathi Alla, resource person of this session, I now invite Dr. P. Nagababu to take over. Nagababu sir, over to you.
Thank you, madam. Good evening to one and all. Myself, Nagababu Patsala, working as Assistant Professor in Department of IT. It is my pleasure to introduce today's resource person, Dr. Kalavathi Alla, a distinguished professor, expert in blockchain technologies, and head of the Department of Information Technology at Vasireddy Venkatadri Institute of Technology. Dr. Kalavathi was awarded a PhD in Computer Science and Engineering from Acharya Nagarjuna University in 2013, specializing in information security. She is a result-oriented techno-functional leader with an impressive 24 years of cross-functional experience. Her exemplary career showcases a proven track record in academic leadership, curriculum design, and the development of teaching and learning practices, making significant contributions to the academic and research community. Her research interests span a wide range of areas, including cryptography, network security, computer networks, cybersecurity, and blockchain technologies. She has published over 36 research papers in reputed journals and presented her work at more than 10 national and international conferences. Notably, Dr. Kalavathi holds two Indian patents, a granted patent title, method and system for processing secret input text stenographically to hide secret input text, and a design patent granted by the Indian Patent Office. She is also a recipient of numerous awards, including Pratibha Puraskar Award from Urban Bank, Acharya Nagarjuna University, Research Excellence Award 2012 from the Knowledge Resource Development Welfare Group presented at IIT Delhi. DST Women Scientist Fellowship awarded for her project title Information Hiding Using Text Steganography for Indian Languages, funded with a grant of 19.4 lakhs for 3 years. Blockchain Academic Excellence Award presented by AICTE in association with IDS for her role as a coordinator of Bharat Blockchain Network Initiative. In addition to these honors, Dr. Kalavathi has successfully completed the prestigious Blockchain Technology Certification course from IIT Kanpur in association with SimplyLearn. Her dedication to advancing blockchain education and research underscores her leadership in this cutting-edge field. It is a privilege to have Dr. Kalavathi Alla to share her invaluable insights and expertise with us today. Thank you. Over to you, Madam.
Thank you, sir.
Thank you, sir. Now I invite Dr. Kalavathi Alla to take over the session. Madam, please.
Thank you.
We're now standing on the precipice of a global revolution of economics, politics, and government. Welcome to the blockchain. Power corrupts, money is power. The power to control the money is one that is now in the hands of those who pretend we can't function without them. So how can we do something about it? Working hard to get a raise, lifting that wage up. Inflation takes it like a hidden taxation. Manipulated interest rates to give the banks a way to create money with the loans that they're giving out daily. That means our money is dead and we gotta pay back more than 100%. No wonder then why the middle class is going under when the ones above them gotta cover and come to collect. And many have no access to banking, making payments or saving, so more fees are taken. And every day the gatekeepers are trying to stop change. We cannot wait. Welcome to the blockchain.
Things are about to change. Open up the gate. Systems get replaced. Reform, decentralize the trust. Security, transparency. The network's run by us.
Bitcoin is a decentralized ledger, and the currency is its first enterprise ever. Secured by the worldwide incentivized network, can't be stolen or controlled by any size effort. You can send it anywhere and instantly. No one can intervene, no third party in between. There's no counterfeiting, algorithm control the outer limit to how many coins can get released. Programmable money, no government can seize it. Payments can be customized by sender and receiver. Contracts written, cementing your agreements with terms that can't be met once you consent that it completes it. Autonomous businesses are possible when profit is distributed amongst those adopting it. Paradigm shift, we must adjust to the end. And with the blockchain, Bitcoin is just the beginning.
Welcome to the blockchain. Things are about to change. Open up the gate. Systems get replaced. Bitcoin. Decentralize the trust. Security, transparency. The network's run by us. Bitcoin.
Now that we got control, we're not gonna let it go. My people all around the globe, we gotta keep building, building, building. Now that we got control,
We got control.
we're not gonna let it go.
Not gonna let it
My
go.
people all around the globe, we gotta keep building, 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 building.
Welcome to the blockchain. Things are about to change. Open up the gates. Systems get replaced. Bitcoin. Decentralize the trust. Security, transparency. The network's run by us. Bitcoin.
Now I welcome you all to the world of blockchain technology with this technical song. Now let us move to the actual technical session. Before going into the world of blockchain technology, let us explore first the evolution of the web technologies. We have Web 1.0, Web 2.0, and Web 3.0 applications. Now, first let us focus on Web 1.0. It is Internet of Connection, Internet of Browsing, Read. That means in case of Web 1.0, we only focused on browsing the Internet. We have just browsed the Internet and we have just got the information, whatever is stored by the server. So all the clients can connect to the server and they can read the information, they can download the data. Only that's it in Web 1.0 applications. Now, coming to the Web 2.0, it is Internet of Information, Internet of Creation, Internet of Interaction, and read and write applications. Not only reading, here the user is allowed to generate the content. Like, for example, in podcasting applications, in social media applications, in tagging, blogging, commenting, and voting. So these are all the different applications where the user can create the data. The user can create the data and he can, creating the data means he is reading the data from the internet and he is creating his own content. He's writing his own data onto the internet. That means Web 2.0 applications, the best example for Web 2.0 is your social media content. So here the user is allowed to create the content and he can experience, he can advertise his data. Now let us go to the Web 3.0. This is described as Internet of Value, Internet of Money, read, write and execute applications. Coming to the Internet of Value and Internet of Money, this is our future of the Internet. It involves a space where people operate a decentralized, almost anonymous platforms like Bitcoin. This means moving away from the big guiding hands of tech giants like Google, Facebook, and Twitter. And nowadays, you might have observed in Facebook also, we are getting a new concept by give, Give, give. Like usually we used to have like, share, and comment. Along with the like, share, comment, nowadays Facebook is allowing a new feature that is give. That means if you like the content, you can share some amount of money, you can transfer some amount of money to the content creator. So this is also one of the application. It is happening from Facebook Meta. This is the best example for Web 3.0 applications. Now, in Web 3.0 applications, we can see the semantic web, worldwide web inventor, and Berners-Lee, and was conceived as a more autonomous, intelligent, and open internet platforms. They have incorporated artificial intelligence and machine learning applications also. Now, coming to the Web 3.0 applications, metaverses, like they create virtual universities. Like recently, AICT has launched polyversities. These are the best virtual universities which we are going to witness in the coming days. The next one is blockchain games, like using non-fungible tokens. You can create your digital ownership and you can play games and everything. Privacy and digital infrastructure, decentralized finance, like you can do your payments through blockchain network using your Bitcoin, Ethereum, and DAO. We have a number of decentralized finance applications. These are all simply represented as cryptocurrencies. And the other application of Web 3.0 is decentralized autonomous organization. Now, let's see the features of Web 1.0. Here we have only user to server communication. 1 minute. Here we have user to server communication. Next, static websites, content browsing, hyperlinking, bookmarking, and read only the web. These are the Web 2.0, which we have discussed just now. Interaction with the online documents, video streaming, interactive advertisement, and pay-per-click, centralized data. And coming to the 3.0, here you have decentralized process, edge computing, live video. Now, let us explore the evolution of the web, the entire evolution of the web, starting from the year 1990 to 2025 and 2050 also I will show you. So we have started our internet using with simple browsers like Netscape Navigator, Internet Explorer, and uh, Mozilla Firefox, that kind of browsers. Later on in Web 2.0 applications for content creation, we have Facebook application, Airbnb, Uber, and then Bitcoin application, sorry, Uber. So these are all your Web 2.0 applications where user can interact with the application, user can share his comments, user can share his reviews. Now, coming to the Web 3.0, the first application of Web 3.0 is Bitcoin. It is not Bitcoin, it is a type of blockchain. Bitcoin is one of the type of blockchain network. This is the first example, first blockchain, that is Bitcoin. Next, we have Ethereum. Ethereum is also one kind of blockchain networks where we can develop a number of smart contracts. So here we can develop smart contracts. And the next one is, the next two applications in Web 3.0 are, one is your maker application, maker, and here maker is, it is an unbiased global financial system, a better, smarter currency, which is developed with here, sorry, this maker, it is developed with DAY.js. DAY.js is a JavaScript library, which helps developers easily to build decentralized financial applications. and the top of your Maker protocol. Maker DAOs, they are the platforms of the smart contracts. I will share you the relevant links at the end of my session, all the relevant hyperlinks to go through your DAI.js, to go through your Maker protocol, to go through the Bitcoin network and Ethereum network. And the other one is, here we have Ocean. Ocean is one of the application. Ocean is one of the application where you store, it monetizes artificial intelligence models and data while preserving privacy. So here we have n number of applications in Ocean nodes and decentralized artificial intelligence, data, NFTs. So these are the different applications of your Ocean protocol or your Ocean framework. I will provide you all the hyperlinks. Just explore the detailed Web 1.0, Web 2.0, 3.0, 4.0, which comes around 2020 to 2030. By the end of 2030, we will explore Web 4.0 applications and we move to the web operating system also. So here you have again a detailed information about Web 4.0, which is a distributed search, and Web 5.0, which is intelligent personal agents, like we are developing a number of chatbot applications. Once the technology is developed, we will soon witness Web 5.0 applications by the end of 2045. So this is all about your evolution of web technologies from 1.0, 2.0, 3.0, 4.0, and 5.0. So as we discussed already, one is read-only application, the other one is read-write, and the other one is read-write and execute applications. Here we have differences between 1.0, 2.0, and 3.0 applications. And another one is, major difference is owning the content, sharing the content. That means here the website content is owned by Google, or the website content is owned by vvitguntur.com, by any web server. But whereas here, you can share the content. That content can be shared to another user, or you yourself can create your own content. Whereas here, you can consolidate the content. So this is the major difference. And one more major difference is banner advertising, interactive advertising, and behavioral advertising. What is the difference between these advertising? Firstly, in Web 1.0 applications, here we have, constant advertises in Web 1.0. But whereas in Web 2.0, we have interactive advertisement. That means while registering to some server, they use it to ask you, do you want to receive any notifications or advertises from so and so applications? So this is what about your interactive advertisement. Now, what is your behavioral advertising? So based on your internet behavior, based on your internet searches, based on your Google searches, based on your YouTube searches, it recommends n number of advertisements, or it recommends, suppose if you search for shirts today, the other day you will be getting those advertisements to your web applications. So that is behavioral advertising. So we have three major differences in 1.0, 2.0, and 3.0. Now, finally, we focus on, like here you see, the associated technologies. Here we use normal HTML, like you can place any search engine, you can place email contents, you can have your peer-to-peer file sharing, like for example, Napster and BitTorrent applications under 1.0. Now coming to the Web 2.0, here we have different frameworks like Ajax. The applications which are developed with Ajax, JavaScript, and using Microsoft.NET, blogs, wikis, and others. Whereas in Web 3.0 applications, you can use search using semantic networks, means using artificial intelligence, database information, ontologies. For this, we use ontology-based web language, OWL, which is in the first, Web 3.0 difference. And the last one is intelligent digital personal agents like finally here. This is your Web 5.0. Once we go to Web 5.0, you can witness the full-fledged intelligent digital personal assistants. Now, we have already seen the evolution of web technologies. Now it is our time to explore the evolution of data architecture. Why? Because here blockchain enables under different web technology. It is a different type of database also. It comes, it works with a different types of database. Like during 1960s and 1980s, we worked with Web 1.0 applications like intranet applications. Their entire control was with COBOL and mainframe computers. And we have used notable business models are like Intel and IBM computers. Now coming to the Web 2.0, that is during 1980s to 2000, we worked with SQL and relational databases. And here also the network is internet only. The applications are developed with C++ and Java, and the hardware is servers and data centers. And here we have used Oracle and Microsoft applications to develop such kind of databases. Now we have, in the era of 2000 to 2020, we have used NoSQL, that is not only SQL and graph query languages, to develop your Web 2.0, full-fledged Web 2.0 applications. And frameworks are PHP, Node.js, Python, Spring Boot, and everything. Next, we have the major applications and business networks here are, why? Because Facebook and Amazon, since they allow content creation and everything. Now, starting from the year 2020, we have witnessed most of the blockchain applications. Starting from the year 2020, the Indian government also has released blockchain-based certifications for CBSE curriculum. And we have Web 3.0 applications. They are developed with the Solidity programming language. We learned this programming language on day 5. Now, these are all dematerialized and decentralized applications. And coming to here, we have also several applications like you can place Web 2.0 application as your YouTube, but whereas your Web 3.0 application as D.Tube. So D.Tube is one kind of your YouTube application. And next you have Google search engine in Web 1.0. Similarly, we have presearch.io. Presearch.io is one of the search engine, blockchain-based search engine. And we have Twitter social media network in Web 2.0. Similarly, here we have LBR. That we will see, we will explore all these technologies practically. Now let's move to the actual blockchain technology. Here we have two famous people. One is Scott Stornetta and the other one is Todd Haber. So these two are the pioneers and they have worked in Bell Laboratories. And during the year 1991, he has first written a paper, a research paper on how to timestamp a digital document. How to timestamp a digital document. Frankly speaking, he is not a software engineer. He is not a software engineer. He is not an engineer. He is a researcher in physics. He is a researcher in physics, and he is the famous scientist in physics also. For this purpose, he has received a famous award by name Discover Award for the, he has received Discover Award in the year 1992. He established a company by name, he established a company by name Surety Technologies. While writing this paper, he has taken the help of his friend Scott Haber. He is also he is a cryptographer. He is a software engineer and he is one of the famous cryptographer who has developed uh, blockchain first blockchain application. So these two are the people who has developed an idea to implement blockchain technologies. So uh, we can call these two people as founder and co-founder of network and the father of blockchain network as Scott Stornetta. Now, let's see what is a blockchain technology. Now, first let us see the definition of blockchain. Blockchain is a distributed, immutable ledger which is completely transparent. That means all users can visualize the network. That is what the definition of blockchain network. Now, blockchain belongs to the Web 3.0. Therefore, here we are focusing the blockchain as Internet of Value application. Now, blockchain is a distributed ledger governed by, that means this distributed ledger which is governed by a peer-to-peer network. Now, in simple terms, we can also call it is a distributed database which is accessible and visible to all stakeholders involved to have a trusted and transparent data. That means it is a distributed database. In simple terms, blockchain is a distributed database. Like just as today's internet lets us freely share the information, but tomorrow's network lets us freely share the values. Means freely share the money from one network to another network. Like through blockchain, blockchain initially transformed on targeted fintech space. That means initial blockchain applications are only financial applications like Bitcoin, Ethereum, and all. But afterwards, they have also focused on non-fintech space and they have developed so many blockchain use cases. They have developed so many smart contracts. Almost all web applications can be developed using the blockchain technology. Now, Java also has plenty of libraries to work with blockchain technology. Now, let's see how in this particular definition, blockchain is a distributed ledger. Now, let's see what is a distributed ledger. That means this distributed ledger, it provides data integrity. What do you mean by data integrity? Means it ensures you that the data has not been modified by anyone and anywhere else in the network. During the transmission, you are ensuring that my data has not been modified by anyone and anywhere else in the network. That is the major definition of your data integrity. Therefore, we are saying that distributed ledger is immutable. Nobody can change it. Whereas a table can be modified. Normal database can be modified, but this blockchain database, it cannot be modified. It is immutable data. And this blockchain is a multidisciplinary field where we combine the concepts of cryptography, game theory, and distributed computing. So these are the three major technologies which we use to develop our blockchain technologies. Now here we represent all the transactions on the blockchain and we store all the transactions in a blocks. Like you store in the table, here we use it to call the data stored in the blocks. It is like a table where you store the entire data. And all these tables means all these blocks are connected with your hash pointers. So here we connect all the blocks with hash pointers. Now to to write the triggers and values, to work with such a number of tables, we develop a smart contract, which is by using some programming language, like we use a Solidity programming language, or you can use Python, or you can use Golang, or you can use your JavaScript to develop your smart contract. Always, these smart contracts are self-executable programs. Now, see what is a ledger. Ledger means it is some kind, previously we used it to represent the database like this. but now we are representing our ledger. I mean, why we are saying this as a ledger? Why we are using a business term? It means that when you take any ledger, that ledger contains serial number of transactions. So 1, 2, 3, 4, 5, and so on. Suppose whenever you have received a good, I mean, whenever you have received some items, you cannot go back and write it here. You are not allowed to write it here. If you do something, simply your ledger, your physical ledger display, it represents that you have modified your data. That's what happens in your ledger applications. That is why we store the entire transactions in a block. So we represent a block using this symbol. Now, what is a distributed? Like you all, like we see, the data is stored at all the systems. Your ledger is going to be stored at A, B, C, D, E, and F. We store at each and every one, each and every node. Whereas in a normal application, I mean, normal client server application, the entire data is, I mean, your database is stored at the server. The client can access, the client can store, I mean, he can push the data, he can pull the data from server only. But whereas here, you can store the data in all the nodes, in all the systems of your blockchain network. Whoever is a participant of this blockchain network, they can have the entire database. So that is your distributed. See the differences between centralized and distributed and decentralized. So this is your centralized database. Here we have distributed database at different locations. But whereas in a decentralized environment, we have given peer-to-peer connections from each distributed data. Like see here, we have connected like this. If you connect your distributed data like this, then it becomes a decentralized network. Now, we store ledger at each and everything as we have discussed previously. Now, you may get a question why we require this blockchain. We should enable trust in a trustless environment. How do you enable a trust in a trustless environment? Why I'm saying it is a trustless environment? Your data is going to be stored at each and every node. You are storing your data at each and every node of the network. You are storing your data at each and every node of the network. Then, if everyone can access your entire table or entire database, how do you make this one as a secure? For that, here we use different concepts like integrity, immutability, authenticity. Though it is a transparent to each and every user, we provide confidentiality, authentication, and integrity services. So nowadays, most of the governments, businesses are increasingly becoming digital, and the need for trust, data integrity, verifiability, these are the major, I mean, they have become an imperative in today's technology. Therefore, blockchain is promising due to its features of consensus driven. Means why it is consensus means agreement. So whenever you are going to modify a row or column, or whenever you are going to modify some data stored in a database, you have to take permission from each and every node. Each node should accept at least 75% of the node should accept your recognition. Yes, should accept your change. They should accept your modification. That is your consensus-driven distributed ledger. Therefore, here we have data permanence. Why I'm saying data permanence, how it is permanent? Suppose in a centralized network, we are storing data at server. Therefore, the data location is at only one point. But whereas here, even though if one server is down, even though if one node is down, all the other nodes, they have your data. They are maintaining a copy of your data. Therefore, it provides permanence, immutability, and authenticity. So this is why we require a blockchain technology. Now let's see the emergence of blockchain. When we move from industry 3.0 to industry 4.0, you might have learned 4 V's. But here I have 5 ways: volume of data, velocity of data, variety of data, veracity of data, and finally value of data. You see, volume of data, here we have only storage networks. How do you store your data in the internet or in devices? I mean, secondary storage devices. Next, we have velocity of data. How do you share your information using your internet applications, web applications? How do you share data using the most famous TCP/IP protocol? And the variety of data. How do you, I mean, the data can be stored at single terminal, server, or in multiple servers at multiple locations, or you may store them at clouds, or you may store them in portable devices like mobile phones also. The next type is veracity of data, securing your data. Whenever you share or you store your data at cloud, you should provide data security, integrity, mechanisms to the veracity of data. The final one is fifth V, that is value of data. Means availability, accessibility, data analytics, and data authenticity. Data availability, data accessibility, data analytics, and data authenticity. So this happens through your blockchain technology. Now, the entire blockchain technology works with 9 different steps. First step is your transactions and contracts. Second one is ledger and records, decentralized peer-to-peer network. Next, we have distributed ledgers, cryptographical chain of blocks, consensus and incentive mechanism. And then we go to immutable data, smart contracts, trust and transparency. Let me brief all these topics here. Transactions and contracts. In simple terms, contract means it is a program. It is just like a program you write in Java. Here we write this program in blockchain supported programming languages like Solidity. Transactions, these are the methods in the program. Here we use it to call the program as a contract, which is a smart contract. Why it is a smart contract? Smart contract means it applies artificial intelligence techniques also. That is why we use it to represent them as smart contracts. They protect all your data. Assets means here your data, methods, database, and everything. And they establish and verify identities. Only authorized users can only work with this. Suppose if you have n number of methods, like you have 10 methods in the program, program 1 can be accessed by admin. Method 2 can be accessed by user. Have admin login, user login. You need not develop your application for admin separately, for user separately. In the single method itself, for example, whenever you are writing a function, here itself you can specify this function can be executed by only admin. This function can be, that is how you can develop your transactions. Next, the second one is ledger and records. As we previously discussed, ledger is a database system. It is simply a database where you store your data in a decentralized network. The next one is centralized and decentralized systems. For example, in a digital world, the centralization and decentralization is, for centralized networks, we have all like client server architecture systems. For decentralized one, you can take your Bitcoin, Ethereum. These are the main examples. Next, we have distributed ledger transactions as blocks. Means whenever you write some method, that method are those, whenever you declare a variable, whenever you declare a method, those are going to be stored in the block. That means they are going to be stored in a database. They are going to be stored in a table. So each node have a blockchain network. Each node will get an opportunity to validate the data and to create the block. Each and every participant of this network can create their block and can validate. Once the block is created, you can broadcast your block to all the peers, to all the networks. Each node on the blockchain will be validated by all the other nodes since they have a copy of this particular ledger. Now, these blocks, how do you connect? Suppose there are n number of blocks. How do you connect all these blocks together? They are cryptographically connected together. They are cryptographically chained together. I will explain you in the later slides. How do we connect one block to another block? Now, consensus is the heart of blockchain network. So all the peers have to accept your change, and whenever you are going to modify the data, all the nodes of this particular blockchain network, they should accept your change. The next one is data on blockchain is immutable. Once you declare the data, once you declare some variable as a global variable, and here we use it to call the these global variables cannot be modified at any point of time. So once you declare the variable as a global variable, once you declare the variable as a global variable, you cannot change that variable value later in the smart contract. That is, according to our programming terminology, this is what immutable data. Now, let us see. Here, we represent smart contracts are codified using the business logic. Means we write using some programming language. We developed all the contracts using some programming language. Now, blockchain enables your transactions. Then the meaning of blockchain is you should enable all the transactions in a trustless world. Means enabling trust in a trustless world. Now, see. Let us see the different properties of blockchain technology. It is programmable. You can develop smart contracts using the supported programming languages. It is secure and anonymous. Why it is anonymous? Suppose if you take one centralized system like our banking, we cannot see the entire banking transactions of SBI or RBI or some other Punjab National Bank or whatever it is. But here you can visualize all the transactions of Bitcoin. But though you can visualize, the identity of a person is anonymous. Next, unanimous means whenever anonymous means the identity is not visible, but the transactions are visible, but identity is not visible. Means who is transferring to whom, that is not visible. Next, what is unanimous? Unanimous means all participants should agree whenever whenever you need to transfer, whenever you need to update the data. Next one, timestamp. Timestamp means all the transactions, whatever you are storing, all the functions are there stored with certain timestamp. Next, immutable. Validated records are irreversible, and they cannot be changed. Finally, the last property is a distributed property. Now, here we have the four different people like Airbnb. That is the world's largest accommodation provider, but he has no real estate. Alibaba, the world's most valuable retailer, but he has no single retail shop, but he is selling the goods like our Amazon, like that. Like even Amazon and Flipkarts nowadays, they are opening retail stores, but Alibaba, they don't have any retail store. Facebook, the world's most popular media owner, which creates no content. Facebook is not creating any content. The people are creating the content. People are sharing the content. People are spending their time. People are wasting their time. People are spending so much amount of money on the internet. But who is earning the money? Ultimately, Facebook is earning the money. That should not happen. Next, Uber. This is the world's largest taxi company, which owns no vehicles. Without having a single vehicle, they have created a platform to book the cabs and everything. And now, by inspiring with all these things, the people have created the world's biggest bank with no actual cash. There won't be any physical cash. that is a digital cash. Now let's go into the quickly into our for example, whenever you want to establish a blockchain network, there should be a trust. Trust depends on the value. I mean, for example, you see here, trust depends on value. Value depends on the size. Mutually, when the size is large, trust can be enabled. For example, you see here, if we take salt and sugar, the color is same, but how we trust depending on the taste. So if more number of people say it is something and it is salt or some sugar, then depending on the size of the network, we enable the trust. So therefore, these three are most usable ones to enable your trust. Now, to enable such kind of a trust worthy blockchain network, we use three concepts like cryptography, distributed computing, game theory. All participants have an idea on cryptography, distributed computing, and game theory. Therefore, I am not going in depth into cryptography and distributed computing and game theory. We just explore the different technologies of centralized, decentralized, distributed, and co-located applications. For example, here, if we take the centralized applications are your client server architecture, like a domain namespace, and you can have your any DNS or your any kind of client server architecture, or you can have Amazon web servers, Google cloud computing services. These are all examples. Whereas coming to the co-located applications, high performance computing like HPC, weather modeling, weather forecasting models, DevOps. These are co-located applications. DevOps and net storage area networks are networks attached storage. Network attached storage, NAS, are storage area networks. These are the centralized applications and these are co-located. Now, coming to the combined centralized and co-located applications. Here we have we have VMware operating system like Hyper-V, VMware, Hyper-V. These are the centralized and co-located applications. And you can also have content delivery networks. The next one is centralized and distributed network. Coming, you know the centralized applications already. Now coming to the distributed applications. Here in distributed applications, we have, you might have seen several distributed databases like Cassandra, MongoDB, CouchDB and all. And the major applications are distributed file systems like HDFS, Hadoop distributed file system, and Google file system like GFS. These are the applications of your distributed. Now, combinedly centralized and distributed. Here you have Google Cloud Spanner, GCS. Centralized authentication applications are authenticated data file systems. We have OKTA, OKTA, or Kubernetes. These are the centralized distributed applications. Now, let's focus on distributed and centralized. We already focused on distributed. Let's see the decentralized applications. Now, coming to the decentralized applications, here we have like a version control, in GitHub and in GitLab. So these are your decentralized applications. You can have global networks with centralized monitoring. Like this is one of the application that is Nagios, and blockchain networks like Bitcoin, Ethereum. So these are the different distributed and decentralized networks. So here decentralization is by three different parts, like architectural decentralization, political decentralization, and logical decentralizations. So now decentralize mean physically how you are distributing the computers. Political means how many individuals or organizations can control the data. Logical decentralization using the interfaces or data structure and the data structures. I mean whether your interfaces or data structures are controlled by which type of logic or which type of programming languages, or by using which APIs you are controlling these. We are controlling this kind of logical decentralization. So these are the simple examples of logically centralized and logically decentralized. We can traditional corporate sectors are logically centralized applications. Our democracy is politically decentralized, and civil laws are architecturally decentralized. Blockchain is architecturally decentralized and politically decentralized application. Now coming to the logically decentralized. Here you see, here I am saying it is a centralized, but under centralized applications, why I'm keeping blockchain applications? We have private blockchains, which are Hyperledger and all. You can place them under decentralized. Now coming to the decentralized applications, we have politically centralized and logically decentralized content delivery networks, Esperanto, and here BitTorrent English language. See here it is architecturally decentralized and politically decentralized. Why? Because English, I mean we speak English, there are different rules for for spoken English and grammar for UK and US and all. Therefore it is architecturally decentralized and politically decentralized. And now we don't move, based depending on the time, I am not going to cover this game theory concept. Of course you have pretty well in machine learning and artificial intelligence applications about this game theory and all. Now let's go to the block in what is a block in blockchain. Let's see what is a block in our blockchain. Now we represent the block as a 1 minute. I will explain you. The entire blockchain technology using the platforms. Always we use it to represent the first block as Genesis block, the second block as block 2, block 3, and block 4, everything. And see the detailed model of your block. See here, a block, each and every block contains header, previous block address, timestamp, nonce, and Merkle root. And here, before going in depth into this blockchain technology, I should give some information to you. Whenever we have, in data structures, we have a linked list concept. How do we create one node with another node? Each node contains a data and address to the next node. Address to the next node. Similarly, here we connect a block. This is block 2, block 3, block 4. Each and every block is going to be connected with its previous block hash value. We use the hash value concept. I know you know pretty well about hash value. Since I will show you what is a hash and everything practically here. Otherwise, you may not understand properly. For example, let's go here. Let's go into the blockchain simulator. See here, this is the hash value for empty block. These hashes are calculated based on SHA-256, and here we use one more algorithm, especially in blockchain, we use another algorithm by name KECAC 256. KECCACK, KECAC 256. Suppose if I write something, welcome to the blockchain. Suppose if I write something, see here, there is an enormous change in your hash value. There is an enormous change in your hash value. See, the hash value starts with 4B4. Suppose if I change a small character from uppercase to lowercase, it gives a different hash value. Even if, if I have only one character, even though the size of hash value is same, if I have, suppose you see here, I am increasing the size of content. Though I increase the size of the content, your hash size is not going to be changed. That means it is calculated based on it creates a fixed length hash code on variable size of data. Even if you have a single character, 2 characters, or unlimited number of characters, always it gives a 256-bit hash value. Of course, here the hash is represented in hexadecimal notation. Why? Because it is highly impossible for us to write 256 bits here. That is why they have shown in this thing. Now let's come to the actual block. So this is my block. Here, whenever I click a block looks like this. It has a block serial number. It has a nonce value. It is a pseudo random number. Nonce means only once low. Here we have taken n and ones, only once. That is nonce value. It is a pseudo random number which is 72,608. And here I have hash value for an empty block. Means even the text field is empty. I have calculated a hash value based on the block number and a nonce. Now, if I type something here, welcome to the blockchain or something like this, your hash value is going to be changed. Now, you should mine this value to validate this particular block. It creates automatically a hash value. But to validate this block, to verify this block, I should mine it. Once I mine this block, a new hash value will be created and with a newly generated nonce value, block 1 with newly generated nonce with the same content, and see here, it is 4 zeros 8A 6A. This hash and the previous hash is entirely different. This hash and your previous hash, it is entirely different. So this is all about your block. Now let's see what is a blockchain. See, now here I have 3 different blocks. See, I have 5 different blocks. Each block has its own nonce value and some empty data. See here, I am writing something like welcome. Now, the previous hash value of this block is all zeros. What does it mean? Now, it is a genesis block. That means there is no block before this particular block 1. Therefore, block 1 is my genesis block. And this is the hash value of this block. So, validate this particular block. So, once I mine, this block is verified and the color will be changed automatically. Now, let's go to the second block. I am storing welcome here. Welcome to the, suppose I am writing something here. Suppose if I mine here, you see, what is the value of hash here? 4 zeros 1A 19. See the previous hash value. Here also that is 4 zeros 1A 19 6C, something like that. And this is the hash for empty data. Now, once I mine, you will be getting the mined block. Second block is mined. Now the third block. See here, I have entered some data and I am mining here. So now one block is connected with another block using these. See, the hash of second block is going to be stored in the previous hash of third block. Similarly, let's go to the fourth block. This is how each and every block is going to be connected with hash pointers. So these are your hash pointers. This is how we can connect with each and every block. And now let's see how it is immutable, how everyone can identify the change. For example, see here, instead of writing blockchain, at block 2, I am updating something. So whenever I update, see, that information has gone to node 4 and node 5. See, up to node 2 it is correct, up to block 2 it is correct. But whereas in block 3, block 4, block 5, they have alerted that someone has tampered the data, someone has modified at block 3. So once I mine here, now a new hash value will be calculated. That means each and every node should accept your change. So this is how you have to validate each and every block. So this is about your blockchain. Now we have we have given definition as blockchain is a distributed database. Now all the blocks are at a single user only. Now let's go to the distributed environment. So here we have three different users: peer A, peer B, peer C. You may call in any way, either node A, node B, node C, system A, system B, system C, user A, B, C, like that. Now, suppose if I write something here, I should mine it. And, sorry, I think the network is very slow. Okay, meanwhile, okay. Once it is mined, then only we will be able to write something in the next block. See, totally we have 5 blocks. Suppose if I store the same data at peer B also. Instead of creating a number of blocks, I will just show you 3 blocks only, since we are running out of time. Okay, I will show you only in 3 blocks. So I am storing the same data at peer B also, and I am mining here. See, at node 3, I have this data, and I am mining here. Once I validate all the blocks, see the hash of the last block. Here I have 4 zeros, 6 0, 6F. See, here also I have 4 0, 6 0, 6F. Now the hash of the third block at peer A and peer B is same. Suppose if I have added something here, see, now at peer A, the data has been changed and has validated. At peer B, the data, at peer A in block 3, he has also mined. And what is the hash value here? You see, 4021 AB. After validating the 3 blocks in at peer A, the hash value is 5021 AB. But at peer B, the hash value is 40606FC. See, these two hash values are not same. 1 minute, I will show you. These two hash values are not same. Therefore, since these hash values are not same, you can represent, the change is transparent. Since the hash values are different at peer A and peer B, your modification is not accepted by the blockchain network. This is what simple example for what is a block and how do we connect each and every blocks. So this is what we have written here. So, and these hash values are going to be written using the Merkle root hash. Merkle root hash means it is a parent hash, parent root hash value. I will show you some example for Merkle root hash also. You can directly visualize that one. One minute. This is your Merkle tree structure. See, whenever I enter data, your hash values are going to be updated. So this is the Merkle root hash. See the entire structure here. So whenever I update something here, which are the nodes which are going to be affected? That means this particular block H of C, H of D. Then H of D will reflect H of C and H of D. Means first we calculate hash code on block D. Then we calculate hash code on C. We combine both of them together. Again we combine hash of C, hash of D values. And again we use SHA algorithm. And here H of A plus H of B plus H of C and H of D. This is your Merkle root hash or root hash. You can go through all these tools. Usually we work with several algorithms in our daily applications. Like here you have converters and calculators. Like you have MD5 hash simulator, base64 encoder and decoders, where we use in email security and all. Base64, see here, converters, base64 encoding and decoding, SHA-256 generator, Merkle tree, simple hash, hash calculator, signatures. So you can work with n number of converters with all our, you can work with Bitcoin, blockchain, and Ethereum game theory concepts also. This is like a tool overview. So this is all about your Merkle root hash. Now we see the different types of blockchain. Here we have public blockchain, private blockchain, and consortium blockchain, hybrid blockchain. Now coming to the public blockchain. So this is accessed by each and everyone. Your public blockchains are accessed by all the people. Like for example, Bitcoin. It is a public blockchain. Next we have private blockchain. So these can be accessed by only organizations, enterprises. Consortium blockchain, like all hospitals can can group under a consortium, and they can have a consortium blockchain. Hybrid blockchain, which is a combination of public and private blockchain. Here we have examples of public, private. See here, in a blockchain, we have public and private. Always public blockchains are permissionless blockchains. Private blockchains are permissioned blockchains. For example, under public, we have under public permissionless Bitcoin, Ethereum. So these two are the main concepts in our course. Now, here, private permissioned blockchains, Hyperledger, which is by IBM, and several vendors have developed Hyperledger fabrics, Coda, Quorum. And under permissioned public blockchains, we have Coda, Alastria. That means Coda comes under both permission, both public and under private sector. And another, this is also financial application like Sovereign. It is also one kind of blockchain network. So these are the different types of your public and private blockchain networks. If you go to Hyperledger Fabric, you can see the different fabrics. These are all private blockchains: Aris, Besu, Fabric, Indy, Iroha, and Sawtooth. See here, the number of people who are, how many people or how many users are accessing this, are using this particular fabrics, are using this particular frameworks. So most of the people are using Hyperledger Fabric. Why? Because here the count is 22,366. Of course, it is 1 year before. And we have another, we have some other things like Anancredis, Bevel, Cacti, Caliper, Hyperledger Cello, Hyperledger Solang, and Hyperledger Firefly. If you go to hyperledger.org, then you can, there you can see all these fabrics and all these tools information. Now, for example, here in this hyperledger.org, this was developed by Linux Foundation. I will give you that link also. Now, under permissionless blockchain networks, as we have seen already, permissionless public blockchain, Bitcoin, Ethereum. There are several other blockchains like Jetcash, Neo, Stratus. All these are the several applications of your permissionless public blockchain networks. Another one is permissioned private blockchain networks. Here comes all your Hyperledger concepts, Hyperledger tools. So these are the differences between public, private, and hybrid blockchains. Like public blockchains have trustless, public blockchains are trustless. Why? Because they are shared by most of the people, secure, open, and transparent. And private blockchain, since the network size is very limited, these are very faster and scalable. Whereas hybrid blockchains, they combine both the advantages of public blockchain and private blockchain also. Like they provide security, transparency, and the major advantages of decentralized, like efficiency, scalability, and stability also. So these are the different types of blockchain. Now let's see what is a Bitcoin. It is a Bitcoin. It is a type of block. It is the first application of blockchain network. This was developed by an anonymous person by name Satoshi Nakamoto. Satoshi Nakamoto. Why I'm saying he's an anonymous person means he is not a single person. A group of people have developed this Bitcoin application. Means not even a single person. A group of people have developed your Bitcoin application. They have inspired through Scott Storneta's 1992 research paper, which we have discussed earlier. And they have added a Merkle trace in the year 1992 to the concept of Scott Stornetter, and they have developed a Bitcoin application. The first Bitcoin application was developed with the help of Haber, who is a professor in Harvard, who has graduated with Harvard University and working in Bell Laboratories, and they have developed a Bitcoin application which is fully distributed peer-to-peer system. Now, I will show you how we explore with a Bitcoin application. So Bitcoin gives a cryptocurrency, means it is a digital currency. That digital currency, it is not like our paper currency. Like now see the challenges which are involved in using your bits as money. Like for example, everyone may get a doubt, can I trust the money is authentic and not counterfeit? Can I be sure that no one else can claim that this money belongs to them and not to me? Therefore, here double spending problem. Like the same note, the same coin can be utilized by 2 to 3 persons. So how we address? Suppose in case of paper money, the paper is itself is different. That paper, that kind of paper will not be issued to the normal industries where we have a number of books and all. That kind of paper and your note, money paper is different. And even physical money, we won't see this double spending problem. Why? Because same kind of note cannot be with the 2 persons at 2 different locations. And always the Reserve Bank of India, they audit all our transactions here. Even though we do electronic transactions, we do with physical money, that is why they have full control on our transactions and our paper currency. Now, how do we enable that kind of trust, that kind of transparency with our peer-to-peer electronic cash system? So here it provides a decentralized peer-to-peer network, and using public transaction ledger, we enable our Bitcoin network. Now I will show you how do we enable a Bitcoin network. How do we explore with Bitcoin network? Before going into Bitcoin network, let's see the different types of currencies. The least currency of Bitcoin is 1 Satoshi, 10 Satoshi, 100 Satoshi. These are the different, like we have 1 paisa, 2 paisa, 10 paisa, and 25 paisa, like that. Here we have 1 Satoshi, 10 Satoshi, 100 Satoshi, and finally we have 10 crore Satoshi is represented as a Bitcoin. Next one is a Deca Bitcoin, Centi Bitcoin, Milli Bitcoin, Bitcoin, and everything. So this is how we represent. BTC means Bitcoin, DBTC, CBTC, MBTC, and Micro BTC. SAT means your Satoshi. This is the least currency. And once the blocks reach to 21 millions in the year 2140, Bitcoin blockchain network will expire, and then a new, the additional Bitcoin blockchain network will come in the year 2140. So this is all about your Bitcoin network. I will show you how do we work with Bitcoin network. So here we have I will show you. See, blockchain explorer, blockchain.com/explorer. So this is your blockchain. Here you have Bitcoin blockchain and Bitcoin blockchain and Ethereum blockchain. So these are the latest prices of Bitcoin. Now you can see 1 BTC in INR. So it is almost 80 lakhs and 99,273. But just 3 months back or 4 months back, the value is only 35 lakhs. Now it reached to 80 lakhs 99,273. So this is the value of your Bitcoin. Now, once I go to the Bitcoin, so here you can see these are all the different coins: Bitcoin, Ethereum, XRP, Solana, BNB, Dogecoin, Cardano, Avalanche, Tron. So these are the transactions. See how fastly the transactions are going to be changed. Now we'll go to one Bitcoin. This is the Bitcoin network. This is the current currency is also always it is the price is going to be fluctuating, student. See here, there is a lot of fluctuation in the currency. And here we see 1 minute. So this is the, now what is the block number? 87,000, sorry, 8,72,919. So what is the last block value? 21 million. Once we reach to 21 millionth block, now we have to go for another blockchain network. Bitcoin should have another blockchain network. So this is all about your market information. And here you can see the latest transactions. If I go to one transaction, see here, you can see the entire transaction. Transaction means the financial transaction happened between one user to another user. See, this is not validated till now. That is why we have seen invalid transaction. They have not verified. And for example, if I see here, this transaction is verified. That is why I can see. See the hash ID of this transaction and the amount, how much amount he has transferred from one user to another user. And here see the sender and receiver. These two are the sender and receiver. That, I mean, we can see everything, but the identities are hidden. The identity is secured. You cannot see the actual identity. You can see only the public key or the ID, account ID given to that particular user. So this is how you will get all the details, like what is the hash value. So this is how you can see you can have from this user. This is the actual, here you have only 5 to 10 characters now. So here you can see the actual anonymous ID of sender, anonymous ID of the receiver. This is how everything, each and every transaction is transparent. And all users can see here also this is not confirmed. Why? Because all nodes in your blockchain network, they should confirm your transaction. Why? Because they store a copy of your entire ledger. So this is how you can see the entire, you can explore with this kind of blockchain networks like with Bitcoin, and similarly you can explore with Ethereum also. Not only with Bitcoin transactions, you can even explore with Ethereum blockchain network also. So now the doubt is, okay, we have explored with the Bitcoin and Ethereum. These are the repositories where you can store, where you can purchase the money, where you can, these are the applications where you can purchase the money and transfer the money. But where to, once you purchase, where do you store? Suppose if it is a physical currency, I can store it my physical wallet, or in some financial bank, or in my Almira. But where can I store my cryptocurrencies? Therefore, here we have different wallets. They are like desktop wallets, which can be stored on any operating system, including your Windows and Macintosh operating system. And I will give you all these links. You can install it and you can explore with how you can transfer money from one user to another user. And I request you not to transfer money or not to purchase any amount of money using these wallets. This is your software wallet example, exodus.io. You can download either in Linux operating system, Windows, or in your Mac. Another one is mobile wallet. The same kind of desktop wallet can be installed in your mobile also. You can run these applications on any smartphone with Android or iOS. Next one is web wallet. These are the wallets accessed through a web browser. And now I will show you one web wallet here. The next coming classes, I will show you how to install MetaMask also. See here, I have a wallet like MetaMask. This is my wallet. Since I am installing in the browser as a browser extension, we can represent these are as web wallets. So once you enter here your so this is how you should connect. You can connect with your MetaMask wallet, and you can share your money from one user to another user. This is how you can transfer money, or you can execute your smart contracts. To execute our software programs also, we should have a wallet. Usually we connect with web wallets. Now, this is the link to install your MetaMask wallet. I will share you the entire installation procedure also. Since we are all technically literate people, you can easily install your MetaMask. It takes some 10 to 15 minutes time, which is highly impossible for me, to show the installation procedure also. Now, another one is hardware wallet. Like these hardware wallets, they represent like your USB, like you have your USB. You can see a hardware wallet by inserting your USB device into the laptop or to any desktop. It works like your wallet. Or you can connect with near field communications like using a Bluetooth network also. You can connect this hardware, your USB hardware wallet to the laptop or to the desktop. So this is your hardware wallet, and this is my paper wallet. Like you can generate paper wallets. For example, I will show you one paper wallet here. If you go to bitaddress.org, here you can see your paper wallet. See, to generate paper wallet, a single paper wallet, what should I do here? I have to do some work. That is, to generate the Bitcoin address, you just move your mouse pointer. Once it gets to 100% randomness, once we get 100% randomness, then a wallet will, then it creates one wallet to you. So that means this is your wallet address. See here, this you can share with. That means this is the public key, which can be shared with all the people. That means if they want to transfer money to you, they can use this code. And this is a secret, which is your private key, or which is your account number. Just we use it to say public key and private key, but frankly speaking, this is your some password, or this is your some private key to connect to your wallet. Whereas here, this is the number, this is the public key by using which anyone can send cryptocurrencies to you. That is why you can share with this. Like whenever, even in Phone Pay and Google Pay also, to transfer money from one user to another user, we use such kind of QR codes. So that is a single wallet. And here you can have paper wallet. If you want to generate some bulk number, then you can generate. Suppose here you can have 6 different QR codes and with different public and private keys. So this is how you can work with your Bitcoin, wallets. Not only with Bitcoin, any kind of crypto, for any kind, to store any kind of cryptocurrencies, you can have all these things. So this is the procedure to connect with bitaddress.org to execute your single wallet, paper wallet, or bulk wallets. Now, I think we are already, my session time is over. In the next session, I cover the another type of blockchain network, which is Ethereum blockchain network. There itself, we execute all smart contracts and we build smart contracts. and we learned basics of Solidity programming language. Thank you, one and all. Sai Jyoti,
Yes, ma'am.
you please proceed with the next session.
Okay.
I
Meanwhile,
will
you
stop.
please give the microphone access to Priyanka, ma'am.
Okay.
Thank you, ma'am. Thank you, Kalavathi, ma'am, for your insightful session on overview of blockchain technology. Your expertise and detailed explanations have certainly provided us with a strong foundation for understanding this transformative technology. We deeply appreciate your time and effort in sharing your valuable knowledge with us today.